So how we plan experiment, the last one we were discussing was finding the percentage of the water in the new compound. So washing soda crystals, which are hydrated sodium carbonate. And when we expose them to air and some of the water is lost and a new substance is formed. Whenever you're heating a solid and you allow the water to escape or a water crystallization to escape, you should always heat in a crucible. Crucible is a deep container and it also have a lid. So what is the purpose of keeping a lid even though when you supply heat energy, water will be lost? So what might happen when it is thermally decomposed, some of the solid may escape while heating. So the two reasons to use a crucible because it is deep and we can also put a lid on the crucible easily. So first what we'll do, like the first point, we will measure the mass of the hydrated sodium carbonate. And you should always mention how you are measuring a mass. So by using the name of apparatus is important. So by using a balance, we measure the mass of hydrated sodium carbonate. So this is the first point. Example, we say this mass is M1. Then we will transfer hydrated sodium carbonate into crucible with lid by the help of how I can transfer. If I want to transfer a solid, how I should transfer? Spatula. Whenever you transfer by the help of spatula. That is the second point. To transfer hydrated sodium carbonate by the help of a spatula, then we will measure the mass of content and crucible. Then we will place the crucible on the wire gauze and heat with a Bunsen burner. So heat by a Bunsen burner. Then we will cool and measure the mass. And then we'll repeat the procedure until the mass is constant, like the mass is not changing. Like now we are sure that no more water is given off or no more water is released. So repeat the procedure until the mass is constant. Then the last thing will measure the mass of so we'll measure the mass of a solid left behind. And how to get the water, the last part is about the calculation. So what will be the mass of the water? Why we measure the mass again? It's because we want to make sure that all of the water crystallization will be lost. So, the substance does not change for like all the chemical reaction has taken place. That's why we have to measure the mass of a crucible and a content again. Now, how to work out, like this is M1 and this one is M2. So what is the mass of a water? So mass of a water will be, the mass of H2 will be M1 minus M2. And to get the percentage, because what we need, plan an experiment to determine percentage of a water by mass present in new substance. So we take a difference to know how much water was released And you can now to determine, because like what we did initially, we experiment to determine the percentage of water by mass present in this new substance. So we took a difference here to know what mass of a water is present. And we just multiply like the difference in the mass divided by total mass of a substance into 100, we'll get the mass of a substance. What are the marking scheme points? As you can see here, these are the marking scheme points. So we can heat to dryness as well. Heating to dry, weighing the sample of a washing soda, and heat and remove the water of crystallization, name container like crucible, we cool, reweigh, repeat heating until the mass is constant, and appropriate calculation suggested for the percentage. Any maximum 8 points are given, any 6 are acceptable. Or weigh a sample of a washing soda we did. We heat to remove the water of crystallization. We use a crucible using an apparatus capable of collecting the water vapor. Then we cool and condense, and we continue until no more we collect. And at the last, we measure we weigh the water which is given off. That's like using a condenser, a Liebig condenser, we can also do this. So first, we supply the heat energy, we convert into new substance, and then from this new substance, we condense the water and collect the water which is given off. You need to record the marking scheme answer. So you can also, the second method which is given is you take, like you converted sodium carbonate into a new substance, and then this new substance, when you supply the heat energy to this new substance, you use a condenser. You transfer the new substance into a conical flask, and this conical flask is connected to a condenser. And you place a stopper. When you supply the heat energy, it will lose its water, all the water which is present, and you collect that and measure the mass of this water which you collect. That will be the mass of a water which is present in the new substance. So first we make sure that it has converted into new substance, and then we remove the water from the new substance. So that is what is mentioned. The second method, which is mentioned here, the second point, this one, weighing a sample of a washing soda, heat to remove the water of crystallization, using a crucible, using an apparatus capable of collecting the water. So we can collect how much water is there. We cool and condense, and we continue until no more water is collected. And weighing the water, and what will the percentage? The percentage of a water will be mass of a water we collect divided by total mass of a sample which we use multiplied by 100. Is it clear, this part? Any doubt in this? Yeah, total mass is M1. That's right. Total mass is M1. So there are two ways. Like one is like you take a difference to know how much water was there. One is you collect how much water is given off. That is also correct. So first method, which I explained, this was the first one. This is what I explained to you, like the first points. And this is also another way, like you take in a conical flask, you supply heat, and you collect how much water is given off. So you can do that method as well. Is it clear or no?